equations of motion. We have the acceleration is constant. We don't use the mass. Now, in Newton's laws, we have A is constant, and we need to use the mass. The next level, we finish this, and we need to move here. The next level, energy, work, we have on here. A not equal to constant, and we use the mass. That's it. Then we will start, and we can use here also the momentum, the interaction between objects. Then we will talk about rotation, motion. Rotational motion. We will repeat everything. Equations of motion, Newton's law, the energy. But briefly, we have a vibrational motion. We have fluids and some other selected topics at the end of our semester. We have the first exam here. We have the second exam here. We have the final exam here. This is our course. We have a homework, the last homework on the Newton's law, which is this lecture. We have also applications on Newton's law, which is tomorrow's lecture. And then I will start maybe with you or with myself, and I will record everything for you. The exam review, how to solve examples. I will solve more examples. The review doesn't contain the exam questions, okay? It's just to tell you how to solve. That's it. So don't put in your mind that is the review is the exam, or just with a little bit change in it. There is homework on Newton's law. There is no homeworks on the applications on Newton's law because we have the exam the next week, the next day. And you can submit your homeworks even in the next week. It's okay. You have a time to do that. Okay, let us talk about forces. What is the force? Who can tell me what is the force? When I was in your place or before, our instructors asked us about the forces. What is the force? We thought somebody asked answered as It's a power, it's an energy, it's a push, it's I don't know what it is. But it's the force is the physical quantity that represent the interaction between two objects. For example, this is the air. This is me. There is a force between me and the air, which is the gravitational force. It is an interaction language between objects in nature. If I am walking, okay, there is an interaction between my foot and the ground. I push the ground backward, the ground pushed me forward. Because of that, I am walking like this. When I push backward, then the ground pushed me forward. This is Newton's third law, you know about it. So this is the force. It is the interaction between the objects. We have many shapes of these forces. We have pushing and pulling. We have a rotational force like this. This is a rotational force. We have also contacting forces and non-contacting forces, just like the gravity. There is no need for the object to contact the ground, the earth, to attract it. Also, there is no need to two magnets to contact, to have a force between them, right? But if I need to walk, I should contact the ground. If I need to push something without any magnetic or electric or gravitational force, I need to contact. If I need to pull something, I need to contact. Also, we have 4 forces in nature. Our God created these forces for us. One of them is the gravity. One of them, the electromagnetic force, which is the interaction between charges and the magnets. One of them, or the other 2 of them, are nuclear forces inside the nucleus. The force, we will see that the force is a vector quantity. It is not a scalar. So it has a magnitude, direction, and the unit. What is the unit of force? The unit of force is Newton, which is capital N. And it has a direction, as we said. Name of sub forces, you can see that. We will study also the friction force, the normal force, we will see them, and you will apply these forces in the lab. We have something called superposition of forces. Superposition of forces, simply, it is adding of force of vectors. Let us now, this is a ground, some ground. This is a box with mass M, and we have a force on it. The force is a vector quantity. It directs to the positive x direction. Okay? Then this object may or may not move to this direction. It will not move to the opposite direction. Even if that force is pulling, it is pushing now. I need to ask you now, what if this force is equal to 5? And there is another person is pushing by another force, which is 2. How much the total force acting on this object? Because these 2 forces are 2 vectors. One of them is 5, the other one is 2 in the same direction. Then the resultant force, Fr, is equal to how much? Simply, it will be 7 the unit is in Newton. We will see what is in Newton is equal to. What if we have a friction force? The friction force, it is not bad force always. Sometimes or many times, the friction force is good for us. We will study the friction force and you will see what I mean. The friction force, it is an interaction force between an object and a contacting other object to it. If I need to push this box, there is a contact between this box and the ground. This contact will appear as a friction force. If I need to push forward, this friction force direction is backward. So I have friction force backward. It may be equal to, for example, to 3 in my example here. So I have 7 forward, I have 3 backward. How much the resultant force now after the 7 plus minus 3? It's minus. We have vectors now. Now the resultant force after all of this, F is equal to 7 minus 3, which is 4. In I direction. I am talking just in one direction now, right? What if I have a force not in X or in Y? Sometimes I have a force in Y, like this. I am lifting the mass. I am leaving the mass, the air, the ground, will attract it downward. I have vectors. As you know, we just finished the two-dimensional motion. I will use it. Simply. What if I have, this is X direction, this is Y direction, and this is my mass, my object now. I will not talk about mass. And I apply this force on it. Assume this force is equal to 10 newtons. What is the direction of the motion? I should give you theta. Is it given here? This example is 30. As you know, I have a vector with the direction. I have X, Y direction. Maybe this XY direction are horizontal and vertical. Maybe they are here. The ground of the room. This is Y and this is up, which is Z. And I have this force. 10, and this is theta 30. I am pulling the object in this direction. Then the object will start moving or will start affected by this force. And I have two components. I have Fx and also I have Fy. How can I find that? Fx is equal to what? The magnitude of this force multiplied by sine or cosine? I'm asking now. Cosine. Why? Is it because I am in X direction or because I have the angle from that direction? Because I have the angle from that direction. So I have cosine 30. Here it is equal to F as a length sine 30. In this case, it will be equal. F is 10. The sine is half. This is 5 in newtons. This is 5. This will be equal 10 multiplied by cosine 30, which is cosine 30. 8.66, 0.866. then it will be 8.66 in newtons. The next direction. All of us know how to deal with vectors. Also, now we can deal with forces. These vectors. Just we change the name of the vector from A to F. That's it. Any question about this? I am now talking just about forces as vectors and adding and subtracting forces. I'm not talking about acceleration and Newton's law. What if I have an object here? Page number 3. I have, this is the positive direction, that is the negative direction. We will see later what is the weight. The weight is the force attracting the object downward. Then we have a force downward. Assume it y, Fy in negative direction. If I have this experiment and I apply a force, the object will start moving. If my force is has a magnitude to start to do it move, to act on it and starting the movement. Right. Here, I have a force on this object to downward. For example, this is the eraser. All of you can see it. And this is my coffee cup. There is a force downward. Why? This mass or me or you doesn't go downward. This is the mass. There's the downward force. It is not going downward. But this is the force, the mass starting moving. What is the reason? If I push it in this direction, it will start moving. In this case, I have a surface. This surface, there's a contact between these two objects, the surface and the mass or the object. For example, if my force downward is 5 newtons, there is a reaction force. You will see that it is upward. We can name it. This is Fy in positive direction. We can name it the normal force. It is upward or normal to this surface. It prevents that object to go down that surface. But now, how much this force? If this one is 5, how much is this? Assume it is 3. Then 5 is bigger than 3. Then the object will start moving downward. That's happened many times. If I stand up on sand, then my force downward is bigger than the normal force on the sand. Then my foot will start going inside the sand until the normal force is equal to my weight downward. What if this force is 7? 5 to down, 7 to up, what will happen to this object? It will start moving, it will start flying. Okay, but it is not flying. So how much the force? It is not below, it is not bigger, it is the same. The reaction force or this force will be the same. If the forces are the same, and now I need to start understanding my system, I have the force as a vector is equal to Fx in I direction plus Fy in J direction. It is simple, we know that. How much Fx? This is X. Do I have any forces in X direction? No, I don't have. There is no forces or horizontal forces. What about the Y forces? I have -5 plus 5 in J direction. I have -5, I have +5 in Y direction. In this case, I will not put them like this. I can put them, the summation or the total forces in Y direction. It is equal to 0. Also here, even if I don't have any forces in X direction, I have the summation of X direction forces. It is equal to 0. If my forces in X direction and Y direction are 0, then the total force is 0, and the object is there is no forces of that. Even if there is a mass or a weight downward and the reaction normal force upward. If I ask you, even you will see that in the lab, what is the forces on this car, on this object? You cannot say it is 0. It is not 0. We have two forces. One of them is the weight, the other is the normal. The total force is 0. It's okay. What if I start pushing the car, but it is not moving? I start put small force, maybe Fx is equal to positive 0.01 Newton. It is a small force. There is a friction force here. And this friction force, this is example how, what if an ant is come and start pushing this object? It will not push it. What if I come to push a car and it is stagnant? I cannot push it because the friction force, not because the car is skipping. If I start pushing the car forward or backward and the handbrake is off, I can't push it because it is heavy. We will see that I will push it slowly. But what if the handbrake is turned on? I'll start pushing the car. It will not slide because the friction force is very big to me. So the friction force, I have a friction force in X direction. This friction force will be equal to how much? Now I am asking. It is the same as the normal force, the same concept. If my force pushing is 1 Newton, if the friction force is 0.5, then my force here is bigger. Then the object will start moving, right? But the object is not moving. What if the friction force is 5? I have 1, 5. Then the 5 will win. And the object will start moving in this direction. But the friction force will not move the object. So the friction force should be equal to the acting force. That is if the object stays stationary. And this friction force is named friction force, stationary friction force. But if I increase my force to be 2, sometimes if I increase, then also I cannot push and move the object. That is because friction force stationary can be changed. It will be 2. Then I change to 5. Then it will be 5. Aha. That means the friction force, stationary friction force, is not constant. It depends on my pushing. What if my force is 0? Then the friction force is 0. That is because the particles here is interact with the particles down like this. If I push slow, if I push with low force, then the interaction is low, then the friction force is low. If I push strong, then the interaction is strong and the friction force is strong. But what if I push with the much strong force? Then the particles will break the contact between them and the other object, and it will start moving. The friction force in this case, the stationary friction force, will be removed all. But I will still have another friction force, which is F kinetic, which is you moving, because I am moving and I don't know if you hear. Oh, you can hear the sound, the interaction between my hand and the board. This is because the friction force. But it is the friction force, the kinetic friction force. This one is constant. Maybe it is a 3. It will stay 3 for a constant velocity. It depends on the velocity. So this is the friction force. I'm talking about it because I need to talk about the Y component of the force and the X component of the force, and how to deal with the horizontal components and the vertical components. What if I need to find the magnitude of that force? Yes, it is the same as the magnitude of that vector. The force, it is simply Fx squared plus Fy squared. This is the Pythagorean theorem. And what is the theta of that force? The direction of that force. It is tan inverse to Fy over Fx, simply, as we know from before. And also we can use cosine inverse and sine inverse. Any question about that online, flying here? We are now talking just about vectors. Start solving a problem, we need to start to choose our coordinates, x and y. Originally, we choose this is x and this is y. But sometimes this is not work with us. For example, if we have this head and we have this object, we need to start solving this problem. And the motion along this direction, like you can hear. So it is not suitable to choose this is x and this is y. We can solve it, but it will take more steps to solve it. But if we take this is x and this is y, it will be more simple. Sometimes we have this system and the object is here. It is better to use this is x and y. There is another coordinate system also we can use it. Also in the lab, you will see you have this system. This is a wall, this is the ground, and this is a ladder. it is okay to use it X and Y like this. Sometimes you can use this is Y and this is X, because when the ladders start sliding to move to this direction. So it is okay to choose your X and Y as you like.